Welcome to the final weekly Wednesday webinar for this season. We will be going on a break after this evening. And thank you so much for joining us this evening. We do have an international speaker, although he's an Australian. John Roach has been working as a teacher for many years overseas, all the way through Asia, Indonesia, Korea, China, and currently and most recently in Kazakhstan. John's quite an expert at teaching mathematics and has incorporated many of the well-known Asian techniques such as the bar method into his practice. Today's session he will be focusing on math fact fluency, which as we know can be a real barrier to students progressing in mathematics and having confidence. Now John's just joined us. We have pre-recorded his session because he is in Kazakhstan and we didn't want something to go wrong. So I will be playing that, but John has joined us and hopefully the line stays clear so that he can answer any questions at the end of the session. So without any further ado, I'll hand over to John.
Welcome to the weekly LDA webinar. My name is John Roach and I'm the primary principal at Galaxy International School in Almaty, Kazakhstan. I have a keen interest in teaching mathematics and I've done lots of work with teachers on bar modelling, problem solving and calculations. So what is mathematics fact fluency? Mathematics fact fluency is the ability of being accurate, efficient and flexible when recalling the basic facts in all four operations. Maths fact fluency leads to higher order mathematics. Through automaticity, students free up their working memory and can devote it to problem solving and learning new concepts and skills. Without this ability to retrieve facts directly, students are likely to experience high cognitive loads and produce work that is inaccurate. So I'm just going to share a slide with you now. This slide is courtesy of Paul Chomsky from Reflex Mathematics, and he's done a lot of work with students in maths fact fluency. So you can see in this very simple example of adding two fractions with unlike denominators, there are basically 14 maths facts that are needed. And as we often see in the classroom, students often get stuck after or at this first stage. They're unable to find the lowest common denominator as they don't know their times tables. So the next slide is from a study done by Menon in 2010. He had two groups of students, those with good maths fact fluency and those with rather weak maths fact fluency. So what he did is he gave the students some computational tasks to do, and then they did some brain imaging scans. And you can see in the top picture, this is of the students that weren't particularly fluent in maths. And you can see there's a lot of activity in the prefrontal cortex of the brain. In the bottom picture, you can see this is the students that were fluent and a lot less activity in the prefrontal cortex of the brain. So freeing the prefrontal cortex from computational load makes valuable processing resources available for more complex problem solving and reasoning. So normally when I do training with teachers and parents, I give them 8 questions to do, because if they have good mathematics fact fluency, they should be able to complete the 8 questions in under a minute. So these are the types of questions that I give the parents and the teachers. So we'll go through some slides now which show possibly the most efficient way to do those 8 calculations. So the first problem, we have 35 times 16. Most students do it the traditional way, multiply 6 by 5, then bring up the 3, then do 6 times 3. But the easiest way is to simply double one and halve the other. So we can double 35 to get 70, and half of 16 is 8. So 70 times 8 is 560. So in these two examples of the same sort of problem, the first one, we can double 45, which is 90, and we can halve 18, which is 9. 90 times 9 is 810. In the second example, we double 55, which is 110. Half of 14 is 7. Then it's simply really your 11 times table. 7 times 11, 77, but they're 10, so it's going to be 770. The next problem was a multiplication problem, and most students, teachers and parents would do it the traditional way. But if we use cross multiply, it's slightly quicker. So there are basically 3 steps in cross multiplying. We multiply the 10s first, so we do 3 times 4 is 12. Next, we cross multiply, we do 3 times 6, which is 18. Then we cross multiply 2 times 4. So we have 18 plus 8 is 26. We're going to put 2 up and the 6 down, because the 2 later will go to the 12. Then the third step is we can multiply the units, and we get 12. So we can put 1 up because it's going to go with the 10s. So then we can just bring the numbers that are at the top, add them to the numbers that they correspond to. So it's going to be 1,472. So in this example here, these two examples, we have 13 times 13. So we can cross multiply. 1 times 1 is 1, that's the 10s. Then we cross multiply. 1 times 3 is 3. 1 times 3 is 3. 3 plus 3 is 6. So we've written down 1 and 6, and then we can just do the units. 3 times 3 is 9. In the second example, we start with the 10s first. So we do 2 times 2 is 4. We write down the 4. Then we cross multiply. 2 times 1 is 2. 3 times 2 is 6. So then we have 6 plus 2 is 8. So we have 4, 8, and then we just multiply the units. 3 times 1 is 3. So the answer will be 483. The next problem involves basically recognizing the commutative property of multiplication. So we know that A times B is the same as B times A. So 12% of 75 is the same as 75% of 12, or 3/4 of 12 is equal to 9. So in these following examples, using that property, we can just simply swap. It's going to be the first one, 50% of 16, or half of 16 will be 8. The second example, swap it again, 10% of 32, well, it's going to be 3.2, just dividing by 10. And the last example, 25% of 18, or sorry, 25% of 48, which will be 1/4 of 48, which will be 12. Next, we had the multiplication problem. And once again, most people will do it the traditional way. But if we use a reference point of 100, it's actually a quicker strategy, and it involves less computational load. So what we can do is from 94 to 100, we count on 6. So we write 6 beside the 94. Next, we have 89. So we can write 11 beside it, because it's 11 more to get 100. So the next step is we can subtract, we can draw a diagonal between 94 and 11, and we can subtract 11 from 94, which gives us 83 tens, or 8,300. Next, we can multiply the 6 and the 11, which is 66. So therefore, 94 times 89 is 8,366. In this example here, we're multiplying 97 times 92. So it's 3, we count on from 97 to get 100, and from 92, we count on 8. So we write those numbers beside the numbers that we're multiplying. Next, we draw a diagonal between the 97 and the 8. So we can subtract 8 from 97, which will be 89, or 8,900. And then we can simply multiply the 3 times 8, which is 24. So we're going to have 8924, 8,924. Next, we have a percentage problem, and usually teachers teach the students to do it this way: 17.5 over 100 times 1400. Actually, that's quite a more difficult way for the students to do, so we teach them the 10% strategy, because in this way basically all they have to do is move the decimal point to the left. So if they're finding 10%, it's 1/10. So they move the decimal point one place to the left. So 10% of 1,400 is 140. So we found 10%. Next, we can find 5%, which is half of 140, which is 70. Then we have to find the further 2.5%, which is simply half of the 70. So then we can add those three different components up and we get 245. So in this example, we have to find 12% of 4,000. Well, we find 10% first, which is 1/10. So we move the decimal point one place to the left, which is 400. So next we have to find 1%. Well, 1%, we're going to move the decimal point two places. So 1% of 4,000 will be 40. If 1% is 40, 2% will be 80. So then we can just add the components together. So we've got the 10%, which is 400, plus the 80 is going to be 480. Next, we have a subtraction problem, and the easiest way to do this is using rounding and compensating. So 139 is close to 140, so we can subtract this from 267. So we're going to get 127, but we need to compensate because we've subtracted too much. We've subtracted 140 instead of 139. So we'll get 127 plus 1 is 128. So in this example here, first thing we do is round 259 to 260. So we're left with 125. But because we've subtracted too much, we subtracted 260, we need to give one back or compensate. So it's going to be 125 plus 1 is 126. Next, we have a subtraction problem, and students find this often quite difficult because of the zeros they have to borrow, and that causes a whole host of problems. The easiest way is using the counting on method. So initially this is taught using a number line. So what they want to do is start with the smaller number and count on towards the bigger number. So from 2,873 to 2,900 is 27. Then we do a jump of 100 from 2,900 to 3,000. Then a jump from 3,000 to 4,000, which is 1,000. And finally we do the 8, and then we just add those components together. And we get 1,135. So in this example here, we want to count on from 5,987. So we do the first jump, which is to 6,000, which is 13. The second jump is from 6,000 to 8,000, which is 2,000. And finally, the last jump is from 8,000 to 8,004. And then we simply add those three components up and we get 2,017. In this multiplication example, the easiest thing to do is use the strategy of multiplying by near 100s. So what we can do is multiply 23 times 100, but I've multiplied too many groups of 23. I've multiplied 100 groups instead of 99. So I need to subtract one group of 23. And very simply, students know their number bonds. We just need to subtract 23. It'll be 2277. So in this example here, 76, we'll multiply it by 100. So we get 7,600. Then we can take away one group of 76. So it's going to be 7524. So the next part in this seminar will be about times table and number bonds, because these are two really important factors which help with maths fact fluency. So the lack of ability to quickly recall times tables or calculate number bonds, I believe, are two of the most significant factors in hampering a child's progress in mathematics. So students need to rate learn times tables as well as being taught other strategies. If a child has only been taught times tables through memorization, they have no other strategies to fall back on if they are unable to retrieve this from their memory. So, for example, a child is given a problem where they need to use a number fact of 7 times 8. If they only know memorization and they're unable to retrieve this, they cannot continue working on the problem. So the following slides show some methods that we use to help the students with. So we looked previously using the reference point of 100 to multiply two numbers, but this can also be used for the 6, 7, 8, 9 tables. So for example, with the 7 times 8, we start with the 7. We're using a reference point of 10, so to get from 7 to 10 is 3, so we write 3 beside the 7. To get from 8 to 10 is 2, so we write 2 beside the 8. Next, we can write or draw a diagonal between the 7 and the 2, which is 5. That will be the 10, so we've got 5 tens or 50, and then we can multiply the 3 times 2, which is 6. So 7 times 8 is 56. In the following examples, the first one we have 9 times 7. So it's 1 more from 9 to get 10, 3 more from 7 to get 10. So we draw a diagonal between the 9 and the 3, which is 6. That will be the 10s, 60. Then we can multiply 1 times 3, which is 3, so 63. In the second example, 8 times 6. So count on 2 from 8 to 10, count on 4 from 6 to make 10. So then we can draw the diagonal between 8 and 4. So we subtract 4 from the 8, we get 4, or 4 tens, 40. And then we multiply 2 times 4, which is 8. So 8 times 6 is 48. The next method is using the fingers. So basically, the fingers are numbered from the pinky first, which is 6, 7, 8, 9, 10. So if the students have to work out 7 times 8, so they find 7, which is 6 and 7, then they find 8 on their other hand. So where the two fingers meet and the fingers below, those will be the 10. So we have 2 fingers where they meet, and then we have 3 below, so that's going to be 5 tens or 50. On the top, I have 2 fingers and 3 fingers. These fingers we simply multiply. So we have 2 times 3, which is 6. So if we look at another example, we have 8 times 9. So we find our 8th finger, 6, 7, 8, and over here we have our 9th finger. So we have 2 fingers that join, and we have 4, 6, 7 below. Yes. And then at the top, we have 2 fingers on this side, 1 on this side. So multiply 2 times 1, so it's going to be 72. So another strategy we teach the students is the distributive property of multiplication. So for example, a student knows 7 times 8. Sorry, the student cannot recall 7 times 8, but he knows 5 times 8, or he or she knows 5 times 8. As a student has been taught and has practiced the following, 7 times 8 is the same as 5 times 8 plus 2 times 8. They can use the fact that they know, which is 5 times 8, which is 40. They can use that to find 7 times 8. And sometimes the students will use repeated addition for the 2 times 8, which is fine because actually the cognitive load is less than actually adding all those numbers using repeated addition. Another strategy we use for the times tables is cross multiplying. This is good when the tables, the 11 and 12 times tables. So in this example here, they have a 12 times 11, so they can do the 10s first. 1 times 1 is 1, and they cross multiply. 1 times 1 is 1, they cross multiply the other pair of numbers, which is 2 times 1. So 2 plus 1 is 3. So they got 130, and then they just multiply the units, which is 2 times 1 is 2. So 132. We also teach them this method for the 9 times table. For example, they have to multiply 9 times 9. So the first step is we're multiplying 9 by 9. So the underlying digit is 9. So we need to write down a number that is 1 less than the 9, which is 8. So then we write down the 8. 8 plus what is equal to 9? So it's going to be 1. So 9 times 9 is 81. In this example, 9 is being multiplied by 7. So the first step is we write down the number which is 1 less than the number we're multiplying. So 1 less than 7 is 6. So I have 6 plus what will give me 9? The answer is 3. So 9 times 7 is 63. Second example, multiplying 9 times 5. So the first step is I write down the number that is 1 less than 5, which is 4. 4 plus what will give me 5? The answer is 5. So 9 times 5 is 45. So it's very important that students know the fact families and that they can derive facts from known facts, such as in the previous problem where the student has to calculate 7 times 8, but they know 5 times 8. That will help them arrive at the answer. The second thing that we focus on is number bonds. Number bonds, also known as addition facts, pairs of numbers that make up a given number. Young primary school children are expected to learn number bonds to 10 and then 20. As they progress through school, they also learn number bonds to 100 and 1000. So children are not only expected to be able to understand number bonds, but they should be able to recall them instantly. They should also be able to confidently use the corresponding subtraction facts. So you can see if they know 6 plus 4 is 10, they know that 10 minus 4 is 6. Why are number bonds so important? Knowing your number bonds fluently up to 10 is one of the foundations to more complex arithmetic, such as adding and subtracting with the column method and subtraction to 100 and beyond. It also helps with addition and subtraction, bridging through to 10 or 100. So for example, if the student wants to work out 16 minus 8, they can use the following thought process. They know that 8 is made up of 6 and 2. So first they can subtract 6 from 16 and they'll get 10. And then they have to subtract 2 more, so 10 minus 2 is 8. So quick recall of number bonds is essential. So in the early years, this should be developed through subitizing and also the use of number frames. So subitizing is a term that was coined by theorist Piaget and defines the ability to instantly recognize the number of objects in a small group without the need to count them. So if you have a look at the example below, most people will recognize that there's 3 groups of 5 plus 1 more, which is 16. So you don't need to actually count the individual dots. So in primary, they need to be doing a lot of number bond work, as it greatly assists with the maths fact fluency. If you have a look in this example, 24 plus what will equal 100. As we can see, 24 has units, so the tens must add up to 9. This is should become automatic in the students. So 2 plus what is 9? It's going to be 7, and the units have to add up to 10, so 4 and 6. So the answer will be 76. And students become proficient at this through practice. And if you have a look at the example below, we have 647 plus what will give 1000. Well, the students can see that there are units involved in this problem. There's 7. So the hundreds and the tens, those 2 columns have to add up to 9. So they shouldn't really even have to think about this as students when they see the 7. So it's going to be 3 plus 6 is 9, 3, 5 in the second column, 5 and 4 is 9, so 3, 5, 3. So through teaching this explicitly and doing it in game format, the students can very quickly arrive at the answers for these particular number bonds. So in these 2 examples here, so we know that it's going to be 32 to add to 68 because there's 8 here. Then we just simply add 32 to 57, which is going to be 89. In the second example, through their knowledge of number bonds, the students can quickly see that to get 56 to 100, it's going to be 44 because there's units involved with this 56. So the tens have to add up to 9. So it's 44 plus 33 is 77. So in our school, we basically do 6 periods of mathematics a week. and 2 of these lessons are devoted to maths fact fluency. So the way it's done is generally the first lesson is basically the teaching part of it. And the second part is we use games and other interesting ways to embed that particular strategy. So in this example of strategy of bridging through to 100, the example is 89 plus 67. So what we can do is we can make a bridge through to 100 from 89. So if we look at 67, we can borrow 11 from 67 and add it to 89, and now we have 100. So we have 100, so we've taken 11 from 67, which will leave 56. So it's going to be 156. So maths fact fluency should be taught using explicit instructions. I won't get into this because I know everyone's familiar with it, but I do, we do, you do. So generally that's the first lesson. And after the explicit instructions, students are given the opportunity to practice this skill. And a good way of doing this is through a game. So for the bridging through 100 strategy, the students could play a partner game. So this is just an example. This is called the bridging spoon game. There are 2 piles of cards, a left-hand pile with numbers that are relatively close to 100, such as 88, and another pile of cards which have got numbers less than 100. So the 2 players sit opposite each other. There's a spoon or an object equidistant between the 2 players. So basically the objective of the game is for the students to work out the calculations first, and they need to write it down. Then once they've done that, they grab the spoon, and if their answer is correct, they're the winner for the round. So in this example, the 2 cards that have been turned over is 87 and 44. So we're going to bridge through 100 from the 87. So what we can do is take 13 from 44. So we take the 13, we add it to the 87 to make 100. And then we're left with 31 from the 44. So it'll be 131. So the student who writes it down and grabs a spoon is the winner for this round. I think it's important that the students write down the calculation as well, as that helps embed the process in their long-term memory. So in summary, I guess what we're aiming for with the students is for them to reach a level of automaticity where they can very quickly recall the maths facts with minimal effort. So thanks very much for giving me this opportunity to present, and I hope you found it informative. Thank you.
Well, thanks so much, John. And
yeah, sorry about the quality, Michael. I don't know what happened to the quality there.
But I think it's on my end, unfortunately. Okay. Yeah.
But if I send you the slideshow, you can forward it to anyone who's interested in the slideshow?
Yeah, that's fine. We'll certainly put that up, and we will put this presentation. I mean, it looks fine on my computer, but for some reason, when I put something up secondhand like this, sometimes there seems to be some quality issues. So, but we will put up this presentation on our YouTube channel in the coming days. John's obviously whizzed through a lot of things there. He was going to do the bar method as well, but I thought it'd be too much. I know my head was spinning the other day when you went through that with me, and that's certainly I guess a taster to what can be achieved through maths fact fluency. I just wondered, John, if you'd be able to share how quickly the students I guess become proficient with some of these methods, particularly if you're in an international school. If a new student comes into the class, how long does it really take them to get on, and feel a bit confident with this sort of approach?
Yeah, I mean, it doesn't take them that long, in all honesty. Just by we do reviews each day. We do like a top 5 or top 10. So once we've done the 2 lessons, we've done the first lesson on the explicit sort of teaching, and the game on the the strategy, so the second lesson. Then it's reviewed on a top 5 or top 10, which we do 2 or 3 times a week. Then it's reviewed monthly. So we keep revisiting the strategy. So the students become very proficient with it, and they like it, particularly, for example, you saw the cross multiplying. They like that it actually reduces steps for them. Yeah, the same with the timetable one, because when students forget their times table, they've got nothing if they've just learned it through memorization. So yeah, they really like these strategies. But I think the key is to make it fun for the students. So we do lots of games and interesting things.
I'm just wondering about the spoon there at the end. Is there a significance of the spoon?
No, any object. Doesn't need to be a spoon. Just something to grab, basically. But yeah, I mean, the games, it's up to the teachers. I mean, I've got a whole host of games, and I create games as well. I think that's the key for maths, because a lot of times when students are struggling with maths, particularly the tables, number bonds, it causes them a lot of anxiety. And automatically they've got a negative sort of perception about maths. And I think as teachers, if we can reduce sort of the cognitive load on students for their tables, number bonds, then they're going to start enjoying maths more. Because, you know, for a lot of students, it's a real struggle. And if you can ease that load for them, I think you've got a lot more chance of getting them on side and them achieving in maths.
Sharon's just asked a couple. Well, there's 2 Sharons, one with a double R and one with 1 R. She's asked, how do students with dyscalculia get on with these strategies?
It's difficult for them, I'll be honest. Yeah, we're lucky in the class we have support teachers who can work with the students as well. So they get a bit more one-to-one. And I guess in our school, we're fortunate. Class sizes are quite small. So our class size is from 15 to 20. So probably, you know, less than you're used to in Australia.
And Sharon Wolf has asked, could you demonstrate using the fingers for the 9 times tables, please? Again.
Yeah, sure. Can everyone see? So
no,
I'll just show you my...
Wait there. Wait there.
Can you see my hand?
Like, I don't think... No one can see John, can you?
Can I... Would I share my camera?
We can see him in the small in the gallery, but not big on the
Yeah.
screen.
No,
Okay. Can you see my...
I've just got to get out of this.
Yeah, I can see your fingers, John.
All right, maybe I'll just show you with my... Can everyone see my hand?
Yes, yes, I can see your hand.
Oh, sorry. I'm the only one that couldn't. Sorry.
Yeah. So start with your pinky, which is 6. Yeah. Then you just count up 6, 7, 8, 9 on that hand. And you do the same on the other hand with your pinky, 6, 7, 8, 9. So you've got your 2 pointer fingers together. Yes?
Yep.
Can everyone see that? Yep. So these 2 fingers and the fingers below, so I've got 3 on this side, 3 on this side. So I've got 6 and 2 is 8. So they're the 10s. Yes, I put the 9s together. Yeah. I've got these 2 plus the 6 below, which is 8. So I've got 8 10s. And on the top, I've got my thumb, which is 1. The other thumb, which is 1. So 1 times 1 is 1. So you get 81. Is that sort of clear, or?
That's great, thank you.
Okay, yeah. But it's a really good method for particularly the sort of kinesthetic students. They can use their fingers, and it's great for the 6, 7, 8, 9 times table.
So just to clarify, that works for the 6, 7, 8, and 9 times. From the pinky up to the pointer.
Yep, from the pinky up to the pointer. I mean, most students seem to know their 10 times table anyway. And also for the 6, 7, 8, 9, they can use the reference point of 10 as well, the one I showed before, where they draw the diagonal. So they're two ways that they can do the 6, 7, 8 and 9.
Catherine's just asked, does this method have a name?
I actually just know it as the finger method. But some countries, they've used it. I have a group of Filipino teachers, and they seem to know this method. They call it something else. But I think it was devised a very long time ago by traders in markets who were using their fingers. So I'm not too clear on the history, but I think it's been around for a long time.
Samantha's just asked, can you do another demo, not 9 times? Just a minute.
Sure.
We're slow learners. I'm the same. I'm with Samantha on this. Another repetition, please.
Okay. So this time we'll do 9 times 6. So we'll start off with your left hand. We're going to find the 9. So we've got the pinky, 6, 7, 8, 9. So my pointer finger is 9.
Yeah.
Yeah. Then we're going to get the other hand, and we're going to do 6. So the pinky is going to be 6. So we're going to put our fingers like this, the pointer and my pinky. Yeah.
Yeah.
So we've got 9 times 6. Is that what we're doing? 9 times 6, wasn't it?
Yeah.
Yep. So where the two fingers meet, I've got two fingers, yes. 9 and the 6. Yeah, my pointer and my pinky. And then the fingers below, I've got 3. So in total, I've got 5. I've got 2 plus the 3 below. So 5 fingers, or 5 tens, which is 50. Yeah. Then on the top, I've got 4 on this hand and 1 on this hand. So 4 times 1 is 4. So at the bottom, I've got 5 tens or 50, and on the top, 4 times 1 is 4. So 9 times 6 is 54. How do we go? All right.
I'm just trying to do 7 times 7 here.
Okay, let's do 7 times 7. 7 times 7 is your fingers up from your pinkies. Yep.
Yep.
So we've got 2 fingers that meet. Got 2 fingers below. So that's 4. So that's your 4 tens or 40. Then on the top, we've got 3 on this side, 3 on this side. Then we just multiply 3 times 3, which is 9, 49.
So you still got to know a bit of multiplication there to finish it off, don't you?
Yeah, but it's minimal. It's a help. So hopefully, even if the students use this, it's fine, because basically you want to get them to that level of automaticity where they can recall the number facts within a second or 2. So, I mean, even if they use this, and sometimes they use a bit of repeated addition, that's okay, because basically they're still doing less cognitive load. So it's going to be less pain for the students, and eventually you hope that they'll get to that stage where they can recall it automatically.
All right. Do we have any other questions? John's in Kazakhstan. What's the weather like there today, John?
It's very hot today. It's about 30 degrees today.
Rightio.
So it's a nice time of the year to come. But in January, it's probably minus 20. So yeah, it's quite extreme.
All right. Do we have any other questions? Otherwise, we'll let John go. And thanks so much for putting this together and sharing it with us this evening. We certainly need, I think, in Australia, a lot of support with teaching math fact fluency for students. It's certainly something that many students don't have enough automaticity, and they do, as you mentioned, have considerable anxiety and a lack of confidence towards mathematics. And I do think that if we could get better at teaching it, that would greatly reduce. So thanks so much for your time. As I mentioned before, this will be up on our YouTube channel. We might get you back later on, John, maybe next term, to do something about the bar method, if people would be interested in that.
Yeah, sure. Hopefully it'll be a bit better quality next time. So my apologies for that, because the slides seem to be in focus and out of focus. But yeah, I'll send the slides to everyone.
Yep. And lastly, Samantha just asked, how do we convince others that rote learning is not the be-all and end-all?
How can you convince? Well, basically, if they can't recall it, they've got nothing else to fall back on. I mean, some students, you know, can use the rote method and they can do it quickly and they can remember it. But for other students, if all they rely on is the rote method, they've got no other strategy and they just come up with a blank and they stop. That's it for their, part of the problem. They can't do their times table, like in adding those two unlike fractions. They're stuck in the first stage, trying to find the same, lowest common denominator. So the more strategies you give them that they can fall back on, the more chance that they're going to get, achieve success and be confident, I think.
All right. Thanks so much, John. Thanks for your time.
Yeah, thanks, Martin.
Really appreciate it. Thanks so much.
Okay, thanks very much.
Thanks,
Yeah,
guys. Bye-bye.
bye.